This is a short demo of the PowerLog software. This is PowerLog 3.1. Here we have a drop-down menu which indicates which instruments are connected to the computer. In this case we can see we have 1430 Series 2. We can also access data by opening files which have previously been saved, or we can also access data which has been saved directly to the SD card, which is normally inside the instrument but can be loaded into the computer directly. So here we go to the SD card, select the Fluke directory, and as we do that we now open up a new window which shows which measurements are available on the SD card. There's 8, as we can see, or 9 here. If we choose measurement number 8, we can see the values which have been recorded in this measurement file. So there's a whole range of things, including voltages, currents, power, harmonics, flicker, and so on. This tells us how the instrument is configured for the measurement. Here we can see that the interval here is 250 milliseconds. That means that we took average values every 250 milliseconds, so that's 4 measurements per second. So 4 measurements per second, and we recorded for a total of 1 hour. So that's 4 times 60 times 60. So that's quite a lot of data, considering that we have all of these measured values here. In addition to the measured values, we can also download screens into PowerLog, and we click this box to download those screens. Now we click on download, and the software goes to the file on the SD card. It has to sort through the file to separate each of the events and also the screens that are captured, and then once it's finished it will draw a set of graphs representing those measured values. The first view that you get here is the default view, which is of the RMS values for voltage and current. Here we'll see the graphs build up on the screen. So this is phase 1 or A, this is phase B, C, then the neutral phase, these are voltages, and then on the other side we see A, B and C for currents, and also neutral. In addition to the basic RMS values, there's also some additional values which are, you see these things on each of the tabs. So we see half cycle values, we see fundamental values. There's some grayed out values here. So this one is peak, for example, and the reason why that's grayed out is that we didn't choose to log that during the log period. So that's not been stored in the file and not available for viewing. On the next tab we can see the spreadsheet view. This includes all the values from the measured file. So that includes every value with a timestamp and date stamp and a description of what the value is. The tabs here represent all of the measured values, so the tabs are automatically generated as you load up. So for example, here we can see harmonics, and in this view we see initially the harmonics as a spectrum. It takes one or 2 seconds to come up, and we can choose which harmonics we want to see. So we'll choose or deselect some. So this one is, the first column is the total harmonic distortion, and in addition to looking at this as a cumulative spectrum, we can also look at this graphically over time. So these are the harmonics for the 1 hour period that we measured for, and we can choose each of the harmonics again here as we want them. Another example is the power screen. In the power screen we'll see the measured power. Again, we have some associated values that we can click on or off. So we have reactive power, apparent power, and again we have some values grayed out. Next one we'll take a look at are the dips and swells. This is an interesting view of dips and swells. This curve is a curve called the ITIC curve, which is the curve generated by the computer industry to show the state of the power system. So the curve here goes from an amount of time or number of cycles, and here is the magnitude of voltage compared to the norm. If these events down here, we can see there's 2 small events which are down at the bottom. So this is where we had some dips, and on this table they're represented as being dips which went to less than 5 seconds and lasted between 10 milliseconds and 200 seconds. These dips would possibly affect the equipment but wouldn't do any damage. If you have events which are inside this part of the curve here, then those are events which shouldn't have any effect on the equipment, that the equipment should operate successfully. Then this top sector on the graph, if you have events in this part, they aren't really allowed because potentially they could damage equipment and cause equipment to reset and cause other problems. Once we have a file like this, we can go to the file system and save that. So here we go to Save As, and we can give our file a name. So we'll call this 432 test file, and now we can recall that whenever we like to create reports. The file is quite large, so it takes a few seconds to save. In the file menu we can also create a report, so we'll print a report. The first thing that we have here is that we can choose a logo, so we could put a Fluke logo on here. This gives a summary page if we want to include that. This tells us about the date and time of the report that we'll create. And here we can select or deselect values that we want to include in the report very simply. So we'll say OK, this is our report. It's given a warning message here about our graphic is blank. That's fine, we don't want to show that right now. So we'll say yes. Here we can choose a printer that we want to print the files to. And in this case we'll choose a PDF file, which will be something that we could create the report as a PDF. Here we have to give this a title, so we'll give it the same title, 432 test report, now saved as a PDF, so it's not going to overwrite the information that we had previously. We save that, and now it generates the test report automatically, and we don't have to do too much work to get the report built. And this is really useful for users in that they can take this data and then share it with other people to make decisions about what they want to do about the problem, and it shows whether the power system is good or bad. In this case, this report is taking quite a while. Typically on a smaller set of data, this report will just take a few minutes. We can see that it's creating a number of pages. We're up to page 10 already, so that's quite a comprehensive report, and we can view the report by clicking on test report here. And now we can see the report that we've made. We can scroll through that. We get these sets of graphs of the voltage. Some of these are blank because we don't have data in those. With a more judicious selection of dates and times, we get better sets of graphs, but you can quickly see how easy it is to make graphs or make the report. So hopefully that gives you some good ideas about how to demonstrate the software. It just takes a few minutes to show some of the nicer features like the reporting, like the graphs. We can also export this data as well if users want to put into something else like Excel.